Alright, with problem number 13, if a number x is added to the terms of a geometric sequence, the result is -1, 5, and 2. What is the sum of the original series? So a geometric sequence, if you recall, has the basic form an initial value, then each term after that is arrived at by multiplying the initial value by, or the preceding value, by a common ratio, which we'll call r. So if the first term is a, the second term would be a times r, and the third term would be a times r, or ar squared, etc. And so that's how we would find the terms of the geometric sequence. Now if each of those terms then is if x is added to each of those terms, we're going to get the results -1, 5, and 2 respectively. And so we would have a plus x would have to equal -1, and then we would have a r plus x is equal to 5, and finally ar squared plus x would be equal to 2. So what you have here is three equations with three unknowns. We need to solve this system of equations, and then we come up with the values, initial values for a and r, which we can then plug into the original sequence and find the sum of those three terms. So one way to go about this, and there may be obviously many different ways of doing it, is I can solve for a in the first, and I would get a is equal to -x minus 1. With the second term, I can then substitute a for -x minus 1 times r plus x equals 5. And my goal here would be to solve for r in terms of x. So if I had -x minus 1 is times r is equal to 5 minus x, then r would be equal to 5 minus x over -x minus 1. And if I wanted to make that a little bit nicer without the negative, leading negative in the denominator, I'd multiply the top by -1, I'd get x minus 5 over x plus 1. So now I can substitute for r and a in the third equation, and I would get, if I pull out the negative from that, x plus 1 times x minus 5 over x plus 1, quantity squared, plus x, and that all has to equal 2. So I can cancel an x plus 1 with an x plus 1, and I'm going to end up with -x minus 5 squared over x plus 1 plus x is equal to 2. And if I were to multiply both sides by x plus 1 at this point, I would get -x minus 5 squared plus x times x plus 1 is equal to 2 times x plus 1. Alright, not too bad there. So if I multiply this out, I would get x squared minus 10x plus 25, then plus x squared plus x, is equal to 2x plus 2. And again, -x squared plus 10x minus 25 plus x squared plus x equals 2x plus 2. and I can see that my x squares are going to cancel, which is great, and I will end up with 10x plus x, which is 11x, minus 2x, which is 9x. Now all of my x terms are gone, and I have negative 23 minus 2, which will bring me to negative 27, and that's equal to 0. And 9x is 27, so x is equal to 3. So once I know that x is equal to 3, I now have r is equal to negative 2 over 4, which is negative 1/2, and x is equal to 3, so a is equal to negative 3 minus 1, which is negative 4. So now I know my original values of a is equal to negative 4, r is equal to negative 1/2, and x is equal to 3. Now I should just check these out to make sure that they work. In the first equation, a plus x would be negative 4 plus 3 would be negative 1, and so that checks. In the second equation, a is negative 4, r is negative 2. Multiplying them gives me, r is negative 1/2. Multiplying them gives me positive 2, and 2 plus 3 equals 5, and that checks. In the third equation, a is negative 4. R squared would be positive 1/4. So negative 4 times positive 1/4 is negative 1. Negative 1 plus 3 equals positive 2. So that checks. And now all I need to do is find a, which is negative 4. So I want a plus ar plus ar squared, and a being negative 4 plus negative 4 times negative 1/2 plus negative 4 times negative 1/2 squared, and that gives me negative 4 plus 2, and finally minus 1. So negative 4 plus 2 is negative 2, minus 1 is negative 3, and that would be my answer to this one. Alright, so there's a lot of work involved in that, but one way or the other you have to set up those three equations, solve them simultaneously, and find the values for a and r, reconstruct the initial sequence, add the terms together, and get negative 3. So that'll do it for